even monkeys will choose to sleep with a blanket if they're provided the option. Blankets are comforting, prevent distractions, and the extra warmth helps us fall asleep at night. But blankets aren't always good. Too much warmth from a blanket throughout the night is actually very disruptive to our natural sleep cycle. The Earth also has an insulating blanket around it, an atmosphere filled with heat-trapping gases. And similar to our blankets, there's a fine line between being helpful versus harmful. For example, the Earth would be 60 degrees Fahrenheit cooler and frozen without greenhouse gases. But human activities are continually thickening Earth's atmosphere, and so the ecosystems and the societies worldwide are being harmed because of the extra warmth. Activities like driving cars and farming emit several pollutants into the atmosphere. But because each pollutant contributes to warming in different ways, Earth's blanket is actually more like a quilt, where every pollutant is a different patch. My research as a climate scientist is to determine which pollutants matter the most so that we can shrink this quilt and prevent catastrophic warming. There are three main characteristics that we use to determine how a pollutant contributes to warming. Number one, intensity. Intensity is how effective a pollutant is at trapping heat, or the thickness of the patch. Carbon dioxide, the most well-known greenhouse gas, would actually be as thin as a bed sheet, not that potent per pound. But black carbon, commonly referred to as soot, would be a patch a mile thick, because it is 1,000,000 times more effective at trapping energy than CO2. Number two, quantity. Quantity is how much of it we create, or the size of the patch. So black carbon might be the thickest patch you've ever seen, but if it was the size of a square foot, then CO2 would be a patch the size of a basketball court, because we are emitting thousands of times more CO2 than black carbon every year. Number three, duration. Duration is how long a pollutant lasts in the atmosphere, or how long the patch stays on the quilt. Now, CO2 can last virtually forever in the atmosphere. So those basketball court-sized patches are actually building up over time. Black carbon, on the other hand, the mile-thick square-foot patch would disintegrate from your blanket after about a week. And so now that we've constructed the world's most unusual quilt, the combination of intensity, quantity, and duration help us understand why we have different strategies for dealing with different pollutants. We must reduce emissions of CO2 to prevent warming for centuries, but we must also reduce emissions of potent short-lived pollutants like black carbon to reduce warming during our lifetimes. Because I have a dream that one day my children will live in a world that is not too hot and not too cold, but just right. And when I dream, I sleep with my quilt. Thank you.
That was a really lovely analogy. I feel like I learned something. That's great.
Great.
Yeah, and you are building a very lumpy quilt, aren't you? So can you tell me a little bit about your research in particular about this quilt, since you're a quiltologist?
Absolutely. So I focus on short-lived climate pollutants in particular. So those super thick patches that don't last very long are what I work on. So that includes black carbon. It also includes methane. A lot of people are familiar with that as a greenhouse gas leaked from natural gas, also cows farting. That's the methane gas that's coming out from that. And so that is another type of pollutant that, we need to be wary of because they're super powerful at trapping energy, but they don't last too long in the atmosphere. And so what that means is if we reduce emissions of those now, we can take a huge bite out of warming within the next couple of decades.
I'm now having this picture of this great quilting bee where, there's people like you working on that piece and there's people working on the other pieces, that you described. How do you get everybody on the same page because it is a quilting bee and you've all got to be making the same pattern overall? So how do we get everybody working together? How do you do that?
That is such an excellent point, because for so long there were a lot of people that were only working on CO2, because it lasts virtually forever. 20% of the CO2 that we emit today will still be there in 1,000 years from now. So there are a lot of people that think that is the most important thing, because every time we emit that, it's gonna stay there for a really long time. So there was a whole group of people only focused on those basketball court-sized bed sheets that we're building up. And then a lot of people started realizing, but hey, CO2 is only causing 50% of the warming we're experiencing right now. A third of the warming we're experiencing right now is from the short-lived pollutants. And if we cut those emissions, then we can make a real difference now instead of waiting for the future. And so there became a community of people just working on that. And my organization, the Environmental Defense Fund, we are trying to bridge these two communities together. We call it the AND proposition, where we're trying to explain that you need to do both of these things simultaneously. And we need these two groups to work together, because our best chance at curbing climate change is addressing both of these types of pollutants.
What portion of the warming is from black carbon? And what are the most effective ways to reduce black carbon?
Very good question. Black carbon was my dissertation, so you asked the right person. Around 10% of the warming we're experiencing is from black carbon. Black carbon is really tricky because everything else I talked about was a greenhouse gas. Black carbon is an aerosol. It acts completely differently than the greenhouse gases because it interacts with sunlight as opposed to heat. And so black carbon is also always co-emitted with organic carbon, which is cooling. So they're both, when you have a fire and it's burning super bright, you're emitting mostly black carbon and a lot less organic carbon. But when you have that fire that's kind of like whitish and it's like dying down, that's organic carbon and not black carbon. So we need to find those activities where there's more black carbon relative to organic carbon and reduce those, because otherwise we might be just canceling out the warming and cooling. So to answer your questions, diesel engines are a perfect example of having a lot of black carbon, a little organic carbon, and we have these great particulate filters that can get rid of 90% of the black carbon being emitted from a diesel engine.
Thanks, Ilissa.
Thank you.